Our unit code today is equivalence. Logarithms are exponents. Our daily objective is to graph logarithmic functions, and our lesson comes from 7.3 in the book. It's the second time we're doing this, and it's logarithmic functions as inverses. The only thing we're learning how to do today is graph these logarithmic functions. So if we have y equals log base 3 of x, that's going to be a complicated thing to make an xy table for. So the first thing we're going to do is we're going to change this into exponential form instead. So I'm going to change this to the equation 3 to the y equals x. Now I know these are the exact same thing, so I would rather make an xy table for this. So if I do that, it looks like I'm actually going to plug things in for y. I'm going to take 3 to different powers of y. So I will start putting my -2, -1, 0, 1, 2 over here. And we'll figure out what that is. So 3 to the -2 power, remember we can think of as flip the 3 over. So flip it to 1/3 and raise it to the second power. So the answer here is 1/9. This one would be 3 to the -1, which is 1/3 to the first, so 1/3. This is 3 to the 0. We know anything to the 0 is 1. 3 to the first is 3, and 3 to the second is 9. So we work backwards here. We put in values of y to get our values of x, and then we just graph those ordered pairs. So if I go 1/9 just over a little bit, down -2, 1/3 down -1, 1, 0, 3, 1, and 9, 2. And this is what the graph of the logarithmic function is going to look like. You'll remember that our exponential graphs kind of looked like this. The logarithmics are going to look just the opposite. They'll look like this. Let's try another one. If we had to graph y equals log base 6 of x, I don't want to make an xy table for a log. I'd rather do it for an exponential. So I'll go 6 to the y equals x. And make my xy table. So I've got -2, -1, 0, 1, 2. I put these on the y side because y is my input here. 6 to some power of y will equal an x value. So now I'm thinking 6 to the -2, which is 1/6 to the +2, which makes this 1/36. 6 to the -1 is 1/6 to the first, so just 1/6. 6 to the 0 we know is 1. 6 to the first is obviously 6, and then 6 to the second is 36. So now we can graph these ordered pairs. If I go to 1/36, so just barely anything on the x, and down to -2 on the y. 1/6, -1, 1, 0, 6, 0, sorry, 6, 1, and then all the way out to 36 before it gets to 2. So when I go to graph this, I'm going to connect these dots and make it look like it's not going to reach 2 up here at 2 until it goes way out at 36. So make sure you don't get all the way up to that 2. And that's how you'd graph y equals log base 6 of x. The last questions you'll have today, how does the graph compare to the parent function? We've done this a million times. If we have y equals log base 4 of x minus 3 plus 4, first off, let's identify the parent function. It looks to me like the parent function here would just be the more basic function, y equals log base 4 of x. How has this been transformed? Well, based on this, it looks like it's been moved to the right 3. And based on this, 4. Looking at this one, y equals log base 3 of x plus 2 minus 1. First off, let's identify the parent function, which would be y equals log base 3 of x. And it's been moved to the left 2 and down 1. And our last one, this one would just be y equals log of x. And where has that been shifted? Looks like just to the left 5. So there you go. Those are the only two things on your assignment today, graphing and the left, right, up, and down shifts of the parent function. Should be pretty easy.